Hello and welcome to section 13.4 on logarithms. So at the end of section 13.3, when looking at the inverse functions of exponential functions, we introduced this idea of a logarithm. And though we didn't get into much detail then, we are going to get into a lot more details on logarithms now. So to begin, let's suppose I have an exponential statement, something like a number b raised to the power a is equal to a number c. We can rewrite this exponential statement into its equivalent logarithmic statement as follows. We're going to say this out loud as the log base b of c is equal to a. Okay, so a couple comments here. First, note that the base of the exponential statements, this number b here, is the base of the logarithm. The exponent in the exponential expression, so this number a, is equal to, well, the logarithm itself. And then lastly, the number c here, which is the value of this exponential quantity b to the a, that becomes the input of the logarithms. So let's look at a bunch of examples going back and forth between exponential and logarithmic statements. So to begin, I have 2 cubed equals 8. So the base is 2, and so that's going to become the base of my logarithm. So I'm going to write this as log base 2 of what? Well, of whatever the exponential expression is equal to, right? And that's 8 in this case. So the log base 2 of 8 is equal to the exponent. And the exponent there is 3. Okay, so we say that the log base 2 of 8 is equal to 3. Okay, now when I read logarithm notation like this, okay, the way I read this visually is to think, well, take the base of your log, which is 2, you're going to exponentiate it, and this is going to give you 2 to the third power, and then that's going to equal whatever you're feeding the log. So 2 cubed is equal to 8. That's what this exponential statement here says. All right, so now let's do the others. 5 to the negative second is equal to 1/25th, right? So take the reciprocal and square. All right, so now the log statement would be the log base, well, 5 in this case, because the base of the exponential statement's 5, of the 1/25th is equal to negative 2. 3 to the 0 is equal to 1. This would be log base 3, because 3 is the base of the exponential statement, of the number 1, because that's the value of the exponential expression, and then that's logarithm is equal to the exponent of 0. And then lastly here, we have log base 10 of 100 is equal to 2. Okay, great. So now let's go the other way. So just as I was saying up here, to go from an exponential statement to go from a logarithmic statement to an exponential statement, think, all right, take the base of 2, exponentiate it to the 5th power, so that'd be 2 to the 5th, and then that's going to equal the 32, the thing inside the log. And 2 to the 5th is certainly 32. For these others, likewise, you want to do 3 to the minus 2nd power, and that's going to equal what we're feeding the log, which is a 9th. Log base 5 of 1 equals 0. Well, exponentiate and get 5 to the 0, and that is equal to 1. Okay, so this just gives us a feel for how to go back and forth between exponential and log statements. The next thing I want to highlight here is that when the base of the logarithm is 10, there is a convention here to drop the the base of 10 here when you write out the notation. So base 10 sometimes is referred to as the common log. Okay, so if I see just log, see, notice there's no subscript base written there. This really means base 10. So this is the same thing as saying what's the log base 10 of 100, and as we've just already noted over here, it's equal to 2 because 10 squared is 100. Okay, but when again you don't see that subscript written, okay, it means base 10. Okay, and here's some more examples just to illustrate. So on the left I have just powers of 10. So 10 to the minus third is 1,000th, 10 to the minus second is 100th, 10 to the minus first is 1/10th, and then 1, 10, 100, 1,000, so on and so forth. And over here are the corresponding logarithm statements. See, if I take the log of 0.001, and notice I'm not writing the subscripts now because these are all base 10 logarithms, I'm going to get -3, which is just that exponent as a result. The log of 0.01, I get -2, log of 0.1, -1, so on and so forth. And we see, yeah, these logarithms are simply the exponents of what we see in these exponential statements. Okay. The last thing I want to say here in this video is that on the calculator, you will see a LOG button. Okay, and for this LOG button, this is the base 10. So I encourage you to go ahead and put in log 0.001 and you should get -3. Put in log 0.01, you should get out -2, so on and so forth. Okay, that's a good place to stop, and in the next video we'll just push on with some more examples.